In part 19, we are going to see the assembly mechanism. How to create assembly with mechanism connections and animation. Also, if the moving body is having interference, we can check the interference. We will see these things in Creo. File open. See, I have created to create the mechanism. I have created one ceiling fan components, one shaft, and there is a hub and blades. We will see how to create the assembly in Creo. I am creating the assembly. I am giving the name fan. Component assemble the shaft. First is the shaft. This is a fixed component. For fixed component, we can use either this or this. If we go with this, we have to give the rigid. Otherwise, we can use this default. These are all the connections we needed to give for mechanism. Okay. Here a lot of connections are there. Pin connection, slider, cylinder. Based on the degrees of freedom requirement, we have to select any one of connections. Okay. Now I am giving the default. Okay. Now we have assembled the shaft. Next we need to assemble the hub. It should rotate, so we have to give the pin connection. This axis, see here we can see it automatically takes the required assembly constraints. See here we have to give the axis alignment for rotation, this and this. Then the translational, to arrest the translational movement along the axis, we need to select the surfaces. This surface, rest with this surface. Okay, we have completed. See, this is a optional edit definition. The third one is optional. If you want to give some initial position, we can do these things. I am doing one thing. See here, 0 reference. The hub must be 45 degree with respect to shaft's display, means here I am giving 45 degree. See, we can change the position of the component. Okay. Now I am going to assemble the blade. Blade is also going to rotate with the hub. So we have to carefully assemble the blade with the hub. Also it should not refer, the blade should not refer any of the fixed component references or surfaces. Okay. So I am going to match this surface to this one. Then this surface must go to this one. Similarly, third one, this surface must be this one. Okay. Now we assembled the blade. Drag whether it's rotating or not to check. Okay, it's rotating. Each and every component needed to be checked with the drag. I am repeating this. First one is common, so I am selecting the second two. For this one I am picking this one and this. Similarly the third one. Okay, we have created. Now pick and drag. Okay, we have to check the drag in all the stages. Now I am going to create a mechanism. Application, pick the mechanism. See, these are all the steps we need to follow from top to bottom. First, this is the bodies. In the bodies, one is ground. It always, this is a fixed component, is a ground. Remaining things are moving bodies. Okay. Then if we need to assign gravity force, we can assign. Then the connections, we gave only one pin connection here, so we can see this joint here, see, only one. In this axis only we have to give the drive. Okay. Motors, we need to assign motor for rotating the hub. This is servo motor, so new, we can give any name, fan motor. Okay, we have to select the motion axis, this axis, then go to profile. Here position, velocity, we have to rotational velocity. For example, ceiling fans are 340 rpm, approximately nearer to 300 rpm. So here the unit is degree per second, so I am calculating 300 rpm divided by 60 gives 5 rps, 5 revolution per second, or 1 revolution is 360 degrees, so 360 degree, 1800 degree per second, 1800 degree per second for 300 rpm. Apply. Now we defined the motor for rotation. Okay, then these things are not required now. Then the analysis setting, here we have to set the analysis, here or here we can do. See, I am picking here start time, end time. See, for 5 revolutions 1 second it takes. I am solving this analysis for 1 second, 0 to 1 second. Frame for movie generation or animation purpose, we have to increase. If we give more number of frames, we can see the animation with slow speed, so I am giving 100. The motor, here fan motor added. If we don't want this, we can remove this. If we want to add this, if we assigned more than 1 or 2 motors, we can. If we want to add all at a time, we have to pick this icon. Now only one. This is the start time, end time. Now we give 0 to 1, it automatically takes. If we want to stop the analysis at 0.5 seconds, we have to give 0.5, like that. Okay, now I am going to use all the times. Give run. We can't able to see the count the revolution, so I am increasing the frame to 300. Now I am running 1 2 3 4 5. Okay, 5 revolution completed. For example, now I am controlling this to 0.5. I am we can assign more motors also. For example, see, leave this one, give OK. I am assigning one more motor. In the motor, we have to add new. Here fan motor 2, fan motor 2. Second motor we assigned. I given the motion axis the same. Here the velocity. Now I am giving only 360 degree. Only 1 revolution I am going to achieve in this for 1 second. Giving OK. Now I am going for analysis setting, emission definition, edit definition. Here we have to give the name, proper name. Why we have to give the name means we have to extract this file for analyzing the other results. Okay. Now in the motor, only one is there. I am going to add 2 motors. One, see here, I am increasing the time to 1.5. Here it starts 0 to up to 1, it should run. Then from 1.1 to 1.5, the second motor need to run. Okay. Also I am changing the first motor. Okay, flip is in this direction. I am going to change the second motor direction. Instead of if we flip, okay, I flipped, so the rotation direction changed. Now I am going to run the analysis. Here we increased the time. I also added motor and controlled the time. Now I am running. Yes, first motor is running up to 1 second. Then the second motor starts to run. Only 1 revolution it takes for okay. Okay, now we know how to create the analysis. If we want to check the interference, we need to pick this one. In the collision detection setting, we have to pick the collision detection setting. Here we have to add, see, previously no collision. Now we have to pick this one and give OK. It takes some time to find the results. I am playing. Here we have to select the file, what I told, analysis definition 1. I am running this. It is computing the interference. It takes some time, we have to wait. We gave 1.5 second. Up to 1.5 second we have to reach. This is now 0.3 second completed. The people who is seeing the videos can skip this portion. I don't know how to edit and reduce these portions in movie. So now completed. We have to play. Whenever the interference comes, the animation stops. Now there is no interference, so it won't stop. It will move up to the end. I am moving this to reduce the time. See, in the reverse direction. Okay, now there is no interference. I closed this. Now to create the interference, I am going to add one more shaft. Now I am adding one more shaft. That is the shaft. Okay. Instead of creating default, I am giving right to right, top to top, front to front. Now everything assembled. We need to move. Okay, distance 500. Now we created. We can move some extent also. 600 we can. Okay. Then I am going to assemble the hub. I am repeating this. We can repeat the connections also. For this axis, I am selecting this one. For the bottom blue color highlighted surface, I am picking this surface. Confirm. We have assembled the hub. Drag and check the rotation. It's moving. Also, I am going to assemble only one blade. I am repeating this. Add this blue color highlighted, then this one, then this one. Confirm. Now we assembled. Okay, check the drag. Okay. Now I am moving to mechanism. We already gave drives to this one. Now I am going to couple this hub with this hub by a belt drive. This is not logically correct, but just for practice I am connecting, I am considering this hub as a pulley 1 and this hub as a pulley 2. I am going to connect belt drive. See, in the references we need to select two pulley surfaces. By picking the control we have to select both the surfaces. We have to press the control, otherwise it won't take. Belt plane, I am not assigning any belt plane. We have to assign the belt plane, but for practice not required. You can try yourself. Now I am going to run the analysis. See, in the analysis setting, this we already defined everything. Now we have to run. See, it is rotating. We not gave any motor to the second one, but it's also rotating because of the belt drive. Now we gave two motors, so it's rotating like this. Okay, now we needed to check the interference. So this pick here, collision detection we already defined, so I'm going to pick this one. It takes some time. Once again, no, we have to wait. If you want to reduce this time, we have to give very less time on analysis. The end time, we have to give very less end time. It's going to reach 1.5 second. Okay, now we will check the interference. Just run. It's running. Whenever the interference takes, why the movie not at all stopped? Something wrong. Whenever the interference takes, it stop. Oh, sorry, stop animation. We never picked this one. We have to pick. So it takes once again time. Play current result set. Okay. Sorry, because of the mistake. Once again we have to wait. I did a mistake here. I never picked that collision setting. The video become lengthy because of this error, because of this my mistake. 2 times I did. Viewers can skip this portion. Okay, yeah, now we will run. See, it's rotating. Whenever hits, it stops. See the frame stop. Third, next frame here, when the interference is not there, okay, then interference stops. In this way we can check. Okay, in this way we can check the interference. That's all. This is this mechanism is most useful for kinematic design. By using this we can fix the linkage length in kinematic design. I am opening one more kinematic mechanism. See, I am dragging this. Why I opened this means, see, the fan is a open loop. Now this is a closed loop. How to close the end one is most important. Some people don't know. See here, this one is a fixed link. In the crank we have to assign one connection here. The second we have to provide a connection here. In the third we need to provide connection here and here. So how we did these things means, see, we need to add two connections. See, here one and here one. For this one, in the ordinary assembly also we always add new sets. And here new set, like that we have to add. If you want to change, in this way we have to add, to show that I opened this one. Okay, that's all. Thank you.